see if we can make this go. This is supporting hard drives. When we talk about hard drives, the first night we looked at an SSD. What we're really talking about here in hard drives is storage, large-scale storage, which is also called permanent memory. So when I talk about permanent memory, that's the hard drive or the SSD now. And SSDs, for lack of a better description, are like big flash drives. So learn about the technologies used inside a hard drive and how a hard drive communicates and how a computer communicates with a hard drive. Everything goes through a controller. We have drivers and all those other things. We've looked at the cables. We've looked at the different cables for the different types, the PATA, SATA, and SCSI. A little bit different. Everything, well, they're all different. The SCSI looks like a huge PATA or EIDE or IDE. You'll hear all of those terms. And in the cable, we had the 80-pin and the 40-pin cables. The 80-pin more grounds, much a little bit newer. Learn how to select and install a hard drive. I don't know that there really is, until you get into servers, that big a decision. But when you get into servers, you want to get into something that you can put into your RAID. Probably you want a high speed, high rotation, 18,000 RPM drives, those sorts of things. Yes?
Well, what's the website that we go to register?
It's a break. Learn about tape drives and floppy drives in these things. And then the hard disks or hard drives, different sizes, 2.5, 3.5, 1.8 inch drives. 2.5 small ones go into laptops, desktops. The 3.5 inches, some of they can go into other machines. So we'll do those things. 3.5 inch for desktops. And the amount of storage on these things has changed over the years, but the physical size really hasn't. If you go look at a 40 gig, 3.5 inch disk, it's the same physical size as a 4 terabyte, 3.5 inch disk. Yes?
And just a real quick question, with the 2.5 model for laptops, I installed one on a desktop one time. It didn't last but a very short time.
Yeah, I think that probably has to do with the coolant and the voltages that go into it. And you had to have an adapter to put it on the cable too, didn't you?
It was no.
Or was it serial ATA?
Yes.
Yeah, those will fit. The SATAs will fit, but if you do an IDE, the IDE plug is actually smaller on the floppies. Yeah, they may. And there's no guarantee that that was the issue. When is a hard drive going to fail? Whenever it feels like it. Brand new hard drive could quit tomorrow. One that says it's going to fail could last another 3 or 4 years. You don't know, because they can fail any time. But remember that the 2.5 really are designed for use in laptops. You should use the device that's designed for the equipment. We had a guy, you talk about yours, Phil, we had a guy a few years ago had a 2.5 in his desktop, and it ran for a long time, so I don't know if there's any real relationship there. But the different physical sizes, solid-state devices, given a choice, this is where you want to go. The new drives are hybrid drives, which are kind of a combination of SSD and rotating hard drives. What they really do is, as you write stuff to it, it gets cached into a flash memory, and then it gets written to the rotating hard drive after it has the opportunity to get written there, as it has the opportunity to get written there. There are a number of things that you can do to make them faster, make them slower, but if you make them faster, write-ahead caching, for instance, if you make that go away, it's going to be quicker, but if the machine crashes, you stand a much higher chance of losing the data. Remember back when you had to actually eject your flash drive? It worked most of the time if you pulled it out.
I still do that with Linux.
I still do that out of habit. It probably would work if you just pulled it out, but I had a student one time Came and said, my flash drive says that it needs to be formatted. All I did was just pull it out of the machine. Did you eject it? No. Which was, you know, a pretty bad thing since it was the capstone class and all the capstone documents in the 4th week were on the flash drive.
They have a setting now where you can adjust one way or the other.
The new ones now, what you really needed to do that for was so that all the data actually got written to the disk and that it was ready to be ejected.
Just do it out of habit.
That's what I do too, out of habit. Well, I sometimes do it out of habit. I sometimes just pull it right out. But you shouldn't really have that issue anymore. They ought to be on auto eject as they disconnect from these things now. So the SSDs, advantage, no moving parts. We don't have to do defrags. Can access the information immediately. One of the things you think about in a hard drive, it's rotating. You have to wait until the disk actually rotates under the head to get the information that you need. So you have latencies built into the hard drive just from the physical motion with the read-write head moving back and forth, waiting for the disk to rotate around to where the information is, and then the amount of time it takes to actually read it and go through the wiring system to get back into memory. Because when we're going to read this stuff is from the hard drive, we're going to read it into memory to use these things. Built-in non-volatile flash memory. So we got what non-volatile is now, right? What's non-volatile? Mm-hmm. What's non-volatile? And we'll pick on John. I always pick on John because he panics. What's non-volatile?
You don't lose it when you turn it.
All right. When you turn the power off, it stays there. So that's a flash, right?
All right.
And that's what these things essentially are, big flash drives. Memory in an SSD is called a NAND flash memory. NAND gate is a non-AND when we do these things. This is just the construction type. The lifespan is based on the number of write operations. This is a big deal. The number of write operations. These things do fail. The memory locations do fail. Most of them have an algorithm so that you don't write back to the same location every time, that the write location moves around. So reads are not really a big deal, but the lifespan, writes do affect how long their lifespan is. And I think the newer ones are not as failure prone as they were early on. Expensive technology, but it's really not anymore, is it? What does an SSD cost now? I mean, it costs more than a hard drive, but they're really coming down in price.
128 gigs, like $100.
128 gig, $100. That's not bad, actually. That's not bad. $1 gig. That's really not bad at all, because they were hundreds of dollars, not $800, but several $100 for a much smaller drive early on.
How old are they, though?
Not really that old. Well, they've obviously been around for a long time, but not in large sizes and not in the way that they're mass produced now.
There's a big difference in price and actual write speeds, too, though.
Yeah, the speeds, the write speeds. The write speeds. But they're still going to be faster than a spinning hard drive. Constantly going to be faster than that. If you can only have one operating system, probably is going to go on the SSD. The data you can access, because data doesn't tend to change as quickly as some of these other things do. Magnetic drive, 1, 2, or more platters or discs. The ones that we have back here that we've taken the covers off of have 2 discs, and they spin and they have heads. The heads move back and forth. That's going to create a latency. When we talk about defragging, what defrag is about is so that the read-write head can go to a location and get a lot of information, and then move to another location and get information, so that it doesn't have to move here to get this and then move back to get that to put a single file together. So defrag in a spinning hard drive so that it can read the data quicker. But some of the delays The rotational delay, if we're trying to read something that's going this direction, if we get it to the location when it's at this point, you got to wait for a full rotation effectively to get back there. The read-write head has to move in and out to get to the location. And then once you get the information, it's got to go the read-write head down the wiring system to get to memory. So you have a number of delays, latencies here. In the SSDs, we don't have any of this spinning, the latency waiting for it to spin. We don't have any of the latency waiting for the read-write head to get to the correct location. You still got to read the data down the wiring system, obviously, but those things all help. Firmware controls the data reading, writing, and motherboard communication. In today's hard drives, if you look at the Western Digitals in particular, there'll be a little board attached to the hard drive itself. That's where the controller basically is. You may or may not, I had a hard drive that died one time. Kind of thought it was going to be the controller. Found a Western Digital, same kind, put the controller board on it, got the data off, and then swapped it back, the good controller back to the other good drive. But some of those things you may be able to do, may not be able to do. The read-write heads are controlled by an actuator. The data is organized in concentric circles called tracks. Tracks actually are on a single disk, a single platter. If you have multiple platters, we're going to call it a cylinder. Because if we go down into this thing, and I won't be able to draw it, down into this thing, as you drill down, you actually have a cylinder that goes through it. So if you have more than one platter, they're going to call it a cylinder. A single platter, it'll be called tracks.
Tracks are like the old 33 and 45 records?
Well, yeah, the tracks are, and they got a better picture, I think, here in a minute, but tracks, when we do these things, when these things get created at the factory, they get what's called a low-level format, which writes the tracks in the system itself, and then we're going to have sectors in the tracks. And the size, it depends on the sector size when we do this. When we format the disk, we transform the sectors into clusters. And a cluster can be more than one sector. Clusters are going to be defined now. They're usually like 4K clusters. But a cluster is going to be more than one sector. And these are the storage locations that the operating system, the disk operating system, actually used to put the data. Which means that since we don't have cluster sharing in these things, that if you have a whole bunch of little bitty files, if you have big clusters and little bitty files, you're wasting a lot of disk space. The more sophisticated, that's what some server or operating systems are about, is you can actually do the cluster sharing, that you put a file at the front end of the cluster and it's a small, you can use the rest of it for another one. But read-write heads have to find that information based on the mapping that these things use. Most drives use a 4096 byte sector, 4K, and in round numbers, 4K sector. Hybrid drives use both technologies. The operating system's got to support it. The hybrid drive, both technologies use, means SSD and the spinning disk. It caches stuff in the we'll call it flash portion of the hard drive, and then it gets written to the spinning disk. Which means that the operating system, the program, doesn't have to wait for all of this, because it gets stored over here in this memory until it gets to the proper location to write the information. SSD's nice picture, 1.8-inch solid drive inside an SSD, which looks kind of like just like inside a computer, and it's a bunch of chips. Anybody ever take your flash drive apart?
No. Yeah.
I did inadvertently one time. I had it on the key ring, which is a good way to not leave your flash drive, except I had the case, but the memory part, the flash part, had fallen out.
That's not good.
That's not good. I eventually found it. It was on the floor of the car. which kind of made sense, I guess. But bunch of chips in here to store the information. That's what the solid state's all about as we do these things. The inside, and we looked at an actual taking apart one with some stuff ripped apart. We have the read-write head, the read-write head here, the discs. These things are generally made out of titanium, and then they're coated with a ferrous material, so that you can easily change the north-south orientation. The read-write head will have a little coil in it, and when we create electricity, how's electricity generated? Should pick on Todd since he's a graduate of the EET program, right?
What's the EET program?
If we use a spinning platter, a magnetic field, and a coil, that's what we generate how we generate electricity. A magnetic field and a coil. So we can use the coil to write the north and the south, but when you write it, you got to be able to read it back. And that's where the orientation, the ones and the zeros, the north-south orientation comes in, so that as it goes through this little coil of wire, it actually generates electricity.
Would that be considered, I mean, I hate to ask this question, but would that be considered like the same concept as a brushless motor?
Yeah, something like that, yeah. 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 When you turn the computer off and the hard drive goes off, the read-write head goes into a landing zone so that it can crash. If you move this hard drive, I've made a lot of mistakes, and that's one of them. While the computer is moving, you can make this thing start bouncing, and it can actually do damage to the disk.
A couple of 4 terabyte externals accidentally knock them off the desk.
Knock them off the desk. Remember the clearance, when we're actually these things float or fly above the platter, and the clearance is somewhere around, 10 microns, 10 millionths of an inch or something like that. They're very, very, very close to the surface. Yeah. So you really shouldn't move these things while they're spinning. And when you start doing power management on a machine, remember that every time the hard drive shuts down, the head crashes. So do you want to do it? It's, I don't know, 6-1, and there are a number of different people who have different theories about whether you should or shouldn't let the hard drive turn off, let it go to sleep. SSD is not an issue because there's no crashing there. In the Y2K, everybody remembers the Y2K, and we were just all panicking about the world was going to end because the computers wouldn't know when it was, and you know, they would send airplanes to the moon or whatever else. But I just made that one up. But all sorts of stuff, right, was going to happen. There were people that shut down servers that hadn't been turned off in 3, 4, 5 years. They wouldn't restart because of the hard drives, because they hadn't been turned off. So, 6-1, half dozen of the other. Do you or don't you? This is the better picture. The sectors on this thing. The sectors, low-level format, done at the factory. Way back when, I remember some software on a machine, or actually a menu item on a machine a long time ago, said low-level format. These read-write heads don't have enough energy to do a low-level format. They do a high-level format. When you type the format command, that's going to be a high-level format, not a low-level format. Low-level is at the factory. It writes the tracks and the sectors, so that when we do a high-level format, we combine the sectors into areas called clusters. And the clusters are what the operating system uses to store the information. Low-level sector marking, we just did that, didn't we? Note the same high-level formatting performance for the operating systems installed. Firmware in the BIOS use a logical block addressing to address all the hard drive sectors. The size of each sector and the total number of sectors determine the drive capacity. Way back when, I know, bad circles.
Yeah, that was right.
All of the sectors kind of got drawn from the center. The issue here is the ones on the outside are a whole lot bigger than the ones on the inside. They don't do that anymore. They kind of stagger it, and I can't draw it, so that you may not have the same number of sectors in each track, but they're going to be the same size sector. Because when you get down here, you got a whole lot more trouble reading this little bitty stuff because it's going to go by a lot faster than you do out here. You have a whole lot more room to store the information. Smart self-monitoring analysis and reporting technologies predict when a drive is likely to fail. That may or may not actually do it. We had a server one time that kept getting an error message from Windows that this drive is about to fail, this drive is about to fail, so we replaced that drive. Put in another machine and it didn't fail. Probably not worth the risk if you get the indication, particularly on a server. Probably not worth the risk if you get it's about to fail. The internal hard drive methods, parallel ATA, the EIDE that we've been talking about. Serial ATA, seen the serial ATA, the much smaller connector, smaller wires. The problem with these, when you get into heat, is they're wide cables. They can affect the airflow through the system if you're not careful how you lay those cables out. The external SATA, the eSATA, SCSI, FireWire, USB, fiber channel. Fiber channel, nice circle there, huh? Something that you're probably going to use as a large-scale storage medium from a server, from a database server, where you would have a number of front ends, number of different machines writing to a database on a large storage fiber channel. High speed fiber channel, very expensive when we do these things. eSATA, most of the new machines now are not eSATA, but SATA. SATA, serial ATA, eSATA, external serial ATA, you plug it in. External eSATA, kind of, sort of competing with fiber channel. SCSI, small computer system interface, something that's used in servers for a number of years because they tended to have a much higher rotational speed. 18,000 RPM drives or something like that. Yeah, so that, and well, some of them when they start up, it sounds like an airplane taking off. But high speed, and that back to the rotational latency, it's going to decrease that. FireWire and USB generally going to be something, well, not generally, going to be something connected externally to the system. FireWire was at one time a Mac technology. Has now been ported to a lot of the Windows machines. And that chart, this chart's in your book, which is kind of the history of how long these things lasted when they started, and those sorts of things. SCSI is one of those. If you get into it, there must be about not really, but there's 4 or 5 different. You got SCSI, wide SCSI, ultra SCSI, ultra wide SCSI, and it just goes on and on and on. Each of them going to do a little bit differently. Interface standards define the data speeds, define the types of cables and connections. We know that. Standards developed by the Technical Committee T13, published by ANSI, the American National Standards Institute. So we published them. Again, a table that's in the book, you can look at how fast the data transfer rates from these things, 2.1 to 8.3 meg, and we're down here to the serial ATA up to 1.5 gigabits per second. So that's quite a change, quite a difference as we go down the line here as to what we can do. Hard drives have gotten a lot faster. They had to get a lot faster because they're reading a lot more data now, aren't they? And we talk about Windows being a big operating system. Linux is a big operating system. If you do a full install, you're talking
3.1 gig.
3.1 gig. Golly, that's a big operating system. It really is. And the bigger the operating system, it's probably not going to be as fast, but it's going to do a whole lot more for you. Parallel ATA EIDE standard. 1 or 2 IDE connections, and you've seen those to the motherboard. 2 EIDE drives on each cable. You're going to have a single primary on these things. A 40-pin cable, it's going to be 40-pin. It could have 40 wires or 80 wires. The ones that look a little thinner look like they got more wires, have more ground wires. Makes the signal cleaner as it goes across these things. ATA, Advanced Attachment Package Interface, is for the optical drives when we do those things. Types of payload ribbons, the older 40-pin and the 80 conductor, 40 pins, 80 wires. More grounds. And the picture of them. What this doesn't have, that most of them do have, is a little notch, right? All of this, and you notice that you have a blank here, and they have a blank here. All of these devices, little added parts to keep you from plugging it in backwards. If you plug a hard drive in backwards, it's not going to kill it, but it just won't start. System won't boot. It just kind of sits there. If you plug a floppy drive in backwards, it'll start, but the floppy light will stay on. And this has a red stripe here and a red stripe here. These denote pin 1, and pin 1 should be marked on the motherboard itself, and I think you've seen a lot of those. Direct memory access transfer mode. DMA allows the system to directly access memory, though, whatever has DMA, and you can look into the Windows, look at the system information using MS Info 32, and it'll tell you which devices have DMA access. That was one of the advantages early on of SCSI, is it did have DMA access. Some hard drives do now. Used to be the only thing that I ever saw in there that said DMA on it was a floppy disk, and who really cared? And you don't even have floppies anymore. But 7 DMA modes, PIO, and again, Ultra DMA, these are in the book, but the key is the concept here, direct memory access, so that it doesn't have to go through the CPU every time. The startup BIOS detects the drive and selects the fastest mode that the drive and the BIOS will support. Todd probably remembers way back when you had to actually physically define it. Way back when wasn't really that long ago. When you had to physically define the architecture of the hard drive for the BIOS. There wasn't any auto detect. You don't remember doing that? No, I don't remember. Oh, okay. Well, you used to have to go in and tell it how many cylinders it had. Now, when you want to put a hard drive in, you just put a hard drive in and it auto-detects, which is much, much better for us to do that. So we auto-detect, selects the fastest mode, which is always handy that we have the fastest mode instead of the slowest mode. That allows us to do that. The independent device timing, the chipset feature, a lot of the control is going to be on the board, on the hard drive, and it's going to interface, obviously, with the motherboard through a chipset feature in this thing. Supported by the independent device training, allows 2 hard drives to share the same parallel ATA cable, and we've been doing that forever. 2 hard drives on a single cable, a primary and a secondary. In the 2 cables, or the 2 drives, are going to have a master and a slave. And they have to be jumpered that way, kind of, sort of. There is also going to be, I'll put a C here, but a cable select, where the system automatically determines which is the master and which is the slave. The master-slave relationship's important for the controller.
And what happens exactly if they're both set to master?
It won't work.
Nothing
It won't work because they're both trying to control everything.
What does it say then?
It just don't work.
It says like.
It's not going to tell you, oh, you really messed up, and you put two masters in. You're probably going to get erratic performance. I say it won't work. It may or may not start, but
The drive
you're going to get
slash such and such will not register.
or something. Yeah, you may or may not. You may or honestly may or may not get any kind of a message. If you have a postcard, not the thing that you send in the mail, but a power-on self-test card, you're probably going to get an error there. But most machines, some of the really, really high-end motherboards have that built into them. It goes through, where it goes through post, it gives you a message for every step of the way. And if you have an error, it'll light up the light, and you can go look up in the book what the post error is when you do these things. But these things, just like if you plug the hard drive in backwards, you don't really get a message. It just doesn't start. It spins, but it doesn't do anything for you because it has power to it. Two drives to run at different speed as long as the motherboard supports them when we do these things. So we have in the PATA EIDE area, we can have 4 hard drives in a system. Serial ATA is the system that's taken over. It's faster, more efficient, the drives are bigger, the cables are smaller, and on and on and on and on and on. Supports hot swapping, hot plugging. What's hot swapping?
Hot swapping is when you change the drive
while the system's running. Which in a desktop might not be a big deal. But in a server that takes 8 hours to start, that's a big deal. So you need to kind of look at those things. Connect and disconnect them while the system is running. Says so right there, right? Internal cable length here says 1 meter. And that can be important to you. How big is the case? How far can you go with these things? And also, occasionally, CompTIA likes to ask those kinds of questions. We've looked at the parallel ATA, the EIDE cables, serial ATA, the power connector here, and the data connector, which always kind of surprises me. The power connector is bigger than the data connector. And the speeds, again, the table is in the book. Serial ATA, the motherboard expansion card can provide external SATA ports so that you can have a serial ATA drive externally, and those can go up to 2 meters. System, the slower speed. The SCSI technology, primarily in servers. Although the servers that we're getting now are not really using SCSI yet. The older ones have SCSI in them. The ones that are around here, the one that's over here against the wall, and I think there's used to be one in the back. What did they do with it? There used to be one back there. Those all use SCSI hard drives. The ones that we've been getting lately have SATA drives on them. So the faster speeds, and the SCSI early on, because of they were much faster access, what you wanted on the server. SCSI says supports 7 or 15 devices and an independent standard. These things have a SCSI controller, and then you're going to have, and we saw the cable had a whole bunch of connectors on it, right? The internal cable, if you have an external devices get daisy chained, one to the other. So these things do daisy chain. And they have to be terminated at the end. The internals are self-terminated. Typically, well, a lot of these are self-terminated, but there's a little resistor that gets plugged in, a terminating resistor on them. 7 or 15 devices. Each of these is going to have an address. Like, everybody loves binary, right? Right? Am I doing this right?
Yeah.
that right? And then 1, 1, 1. So we have 1, 2, 3, 4, 5, 6. I missed. What did I miss?
0, 0, 0.
No, I missed that. Yeah, I did, didn't I? That's 7.
1, 1, 0. Oh, no, you got that. 0, 1, 1?
Yeah, 0, 1, 1. So each of these are going to have an address, and they're going to be binary addresses. The 7 or 15, depending on whether it's an 8-bit or a 16-bit, obviously, device. If we're going to have 15 devices, we would have 4 numbers, right? Instead of the 2. Embedded in the host adapter supports internal and external. They're daisy chained. You can mix internal and external, but you're still going to be limited to either the 7 or the 15 devices when we do these things. A physical device can embed multiple logical devices, LUN numbers, which can also be virtual devices. Logical unit numbers are what these are called. This is a much better picture than I sketched out, but we have internal devices going up here, and then the controller here has external devices. The terminator is installed on this one, the host adapter with the internal and external connections. Termination is here. The termination on these is generally, the internal generally going to be a self-terminating device. Terminating resistor and the last one in the chain resists the electrical noise and interference. It also absorbs the excess signal. Just like in the good old days when we used coax in the network, shaking his head, you had to terminate the devices to prevent reflected signals. And that's part of what each of these things do. And then we talk about the categories of SCSI: narrow SCSI, wide SCSI, SCSI 1, SCSI 2, SCSI 3, known as SCSI, fast SCSI, ultra SCSI, ultra wide SCSI, on and on and on and on and on. Serial attached SCSI allows more than 15 devices, smaller, longer, and round cables when we do these things. It's compatible with the serial ATA devices. These are the different plugs. It was really nice when you only had like 2 or 3. And now they just go on and on and on. I mean, when you think about video, how many different video plugs are there now? We used to have like VGA.
Well, there's HDMI, isn't there?
We got HDMI, we got DVI, DVI-I, DVI-D, and then you got, Display port, yeah. So it goes on and on and on and on. The number of, and this same thing, the number of SCSI connectors that you have in the systems. Select and install, and then how to set up a RAID. I've got a RAID demo here, and you've got a lab to do a RAID. I want to do a demo how to do that RAID lab, and then you can do it. You guys have virtual machines, and you'll have trouble with that again on the Apple because it has to be run through Internet Explorer. Won't work with Chrome. That's really not entirely true. If you put the IE tab in Chrome or Firefox, you can use those. But you have to be able to use an ActiveX control. And I think that the ActiveX control is installed on all these machines in here. If it's not, let me know. And just like you did with the other things, I'll put the password in and we can install them. So selecting a hard drive. What kind of hard drive are you going to select? What's going to be your factors in selecting a hard drive? Speed, performance, storage, cost. Whether it's a hybrid drive or not, what does your motherboard support? Does your motherboard support hybrid drives? Are you going to do write-ahead caching? Does it support that? And how hard is it to, you've taken them out, how hard is it to put in a hard drive?
Not very hard.
Not very hard.
Take the side off.
Take the side off, screws out, unplug it, plug it in. You may or may not, depending on the system, and this is more a Windows thing than anything else, when you do your virtual machines, you'll have to activate the extra hard drive to do the RAIDs. if you have it configured as a dynamic drive and you take it out of one Windows machine and put it in another one, it's going to show up as a foreign drive and says, oh, this is really tough. Well, just right-click and say import foreign drive. So nothing really big about that. Match the OS, the hard drive. What does that mean, must match the OS? What's got to match the OS? For real. Because that's the one thing that I think that, well, I think that's the one thing that probably the Mac and the PC have in common is, like, I'll use Western Digital or whatever hard drives. I think that Mac uses, you've got one back there, Mac uses Western Digitals a lot, I think. At least the one that I had that failed was a Western Digital. The file system's going to be different. There is a common file system that each of them can read, by the way, if you're going to take an external and go back and forth. They'll both read FAT. Consult the documentation of the onboard card. What are we going to use these things for? The BIOS uses auto detection to prepare the devices. Yep, this is a Western Digital whatever, or a whatever it is. They will auto detect now and automatically configure it for you. These are the things that we talked about: the drive capacity, how big, the spindle speed, common 7200. If we're going to do a server, we're going to want something around 18,000 or something like that, as fast as possible. The higher, the faster the drive, because the rotational latency is going to be less the faster the drive is. The interface standard, what does the motherboard support? Some of these that you've seen support both of IDE and serial ATA. Cache buffer size range from 2 meg to 64 meg. Buffers we talked about, little holding areas, storage areas for the systems. The 2 power connections, I want to just, these are the steps that are in the book if you have a serial ATA and a PATA connector or vice versa. Purchase an adapter. The adapters typically work. I tried that with a serial ATA to IDE for my laptop because somebody gave me this really like 500 gig serial ATA hard drive, 2.5 inch. So my laptop was a IDE, and you can buy an adapter. The problem is they don't match up. The plug doesn't match up, and there's no room to put a cable in. So do those things. Know your starting point. How's the system configured? And these are the steps. I'm just going to click through them. You can read those in the book. Boot from the startup. If we need software, and typically Windows or Linux is going to go find the stuff for us. The pictures that you've all seen, this is one that this one has multiple hard drives, and these little clicks on them allow you to just take it out so that you can remove them. And if the motherboard and the drives support hot swapping, you can take them out while the system's running and put a new one in. It can be pretty important in a RAID because a RAID is designed to have data redundancy, so that if one hard drive fails, you can keep running. And these are all the things that you've been looking at: screws, 4 screws in it, and then plug it in. You want these things to be stable. This is an opinion. I don't know that you've got to put them in to the point that you could ship them through the post office. But what you want is when they're in a stable state. If you pick the drive, turn the computer off, pick the drive up, and move it, that you're not going to do damage to the system. The IDE cables we've talked about, you've seen, master and slave drives. And if you do a cable select, and I just remember CS is cable select. That was a toughie, huh? The end is going to be the master, and the middle one's going to be the slave when you do these things. So we're going to have a primary IDE, master, a primary slave, and a secondary master and a secondary slave in these things. The primary master is going to be your boot device. Now, the boot device doesn't always mean that that's where the Windows folder is. It means that's where the boot files have to be. And in the Windows system, that's like 8 or 10 files. that actually start the boot and then points to where the operating system is. The parallel ATA, the jumpers, which you really hadn't talked about, on the back of the hard drive you're going to have a jumper block, and it's going to have like master, slave, and cable select. So you pick which you want it to be. The safest way today is probably pick cable select because they should be smart enough to figure out where they are on the cable. And I think that's what most of them want you to do now. This is a really nice picture of the connector, isn't it? And you can see, well, maybe you can't, I can't up here. Here is the notch, and here's the missing pin. Not too many years ago, this missing pin wasn't missing. And then we got the cables with the blanks in them and say, yeah, I got a problem. Then you had to check to be sure that your cable actually would work in your individual plug. Primary channel connector is blue, the secondary is black in these things. So this is going to be the primary and this is going to be the secondary, blue and black. And that's what most of them have been so far. Most of the stuff, the blue is what you do first because in the memory we put the blue in first, the farthest from the CPU, blue. And we do those things. Jumpers, huh?
The hard drive, the black goes to
the secondary. Well, we have primary controller and a secondary controller. Two controllers on these things.
black went to the CD-ROM and DVD.
Well, that usually goes to the secondary controller. The primary controller, the blue, should be your operating system. Should be the primary master should be where the operating system is. This is a picture of the jumper block. Each manufacturer does it differently. To my way of thinking, Western Digital does it the simplest way because they have the labels right next to the pins. Seagate has a little map on the top, and you jump it based on what you want the device to be. Again, cable select, probably the way to go in these things. Set the jumpers. So we had a single drive. Yeah, I forgot about single drive. Single drive is neither master nor slave. It's a standalone. If you configure it as master, the master's looking for a slave. And if you configure a slave, the slave's looking for a master. And then cable select determines which drive is on which part of the cable itself. Why don't we take a break here and then we'll look at RAID. 3, 2, 1, go. This is a hardware RAID, redundant array of inexpensive, used to be independent. Some places say you pick the eye, but what it is we take several disks and combine them into a single drive letter. Physical disk into a single logical disk. The redundant part, and we'll talk about RAID 0, it really doesn't have any redundancy. The redundant part is if a drive fails, then you can continue running. You don't have to shut the system down immediately if a single drive fails. We'll configure a software RAID, hardware RAID controller, works the same way. We'll configure a software RAID. Software RAIDs can have, depending on which one it is, a RAID 0 from 2 to 30 can have 2 to 32 disks, a RAID 5 3 to 32 disks, and a RAID 1, which is going to be our mirror drive, is going to have 2 disks. And we'll look at some other things. There's a little site that is linked off of your website that you can look at to see how these things actually go together to make things work. 2 or more hard drives work together as a single array. Improve fault tolerance, improve performance by writing data to 2 or more hard disks at the same time. And the answer to that is maybe, depending on which kind of RAID that it really is when we look at those things. The types of RAID, spanning, just a bunch of disks. What a spanning does is takes just a bunch of disks and puts them together. This is called a RAID, but it really has no redundancy. If we had several small disks, we could put them together in one logical enclosure and call it E-drive. So that instead of having a bunch of small disks, we would have one big drive letter storage area.
It reads it as one.
Say again?
It reads it as one big one.
Reads it as one big one. Problem is, if you're writing data and the data is written sequentially from the beginning to the end, if this disk back here fails, the whole thing fails. In today's disk world, do you really need to do this? Probably not. 2 hard drives that hold a single volume. When one drive is full, the data is written to the second drive. If any of the drives fail, the whole thing fails. RAID 0, 2 or more physical disks. Writes to the physical disks evenly, so we have 2 disks, and I've got a better image here in a second. And you have a file that comes across. The file gets broken basically into 2 parts. One part goes to the first disk, the other part goes to the second disk. RAID 0 is called striping. It has, again, no redundancy, which means that if one disk fails, in this we can have 2 to 32 software RAID in Windows. If we have 32 disks and one of them fails, the whole RAID goes down. But these, again, are addressed as a single drive letter.
That's one of the practice questions. Remember the ones I gave you?
Yeah.
It's on there.
2 to 32. RAID 1 is mirroring, which we make a mirror copy. We write to both disks at the same time. Writing can be slower because you have to make a copy. Reading is going to be faster because you can read from 2 disks at the same time. This is called mirroring or duplexing. Mirroring is it if it comes from a single controller. Duplexing, we would have one disk on its own separate controller, and the primary and the secondary, one connected to the primary and one connected to the secondary. Mirror, they both be connected to the primary or the secondary. The disadvantage is in the mirroring, the controller is going to give you a single point of failure. RAID 5 uses 3 to 32 disks. It does have redundancy. It has a parity bit that gets written to the system. The data is not duplicated, but there is a ability to reproduce the data from the parity bit. If one disk fails, RAID 6 allows 2 disks to fail. RAID 1.0 is a RAID 1, which is a mirror, right? And a RAID 0, which is a stripe. We've got a 1.0 and a 0.1. The difference between these two, it depends on whether it does the duplex first in the 1.0 and then stripes it, or whether it does the stripe first and then mirrors it, which order they're done in. Combination of 1 and 0, and these take at least 4 disks. What I want to do, what I want to do right now is there is a link in your Moodle page to this cool little site here. What this does, and let's see if I can stand up here and make it run with this thing, is when we click on the RAID controller, it's not going to work for me, is it? When we click on the RAID controller, it should be down, it's in week 2. When we click on the RAID controller, it's supposed to. No, it's not the video. Here we go. So we have the data block coming across, and it splits it up, the data block, into different portions and stores different components on the individual drives. The whole system here is a single drive letter. So this could be like F drive or whatever else. But within it are individual drives where the data gets broken up into different components and written to the disks simultaneously.
That's the one, if one fails, they're all,
Say again?
if one fails,
If one fails,
they're all,
you rebuild the RAID and restore from backup. Okay?
come back up.
This is RAID 0, striping. It is for, down here, it is for, gamers would love this because it's going to make the system faster. And just like in your disk, how many of you have a RAID running at home? A can of RAID, but that's it. So if your single disk fails, system fails, right? You restore from backup. Not a whole lot of difference here if you do that. The trick is have backups.
There wouldn't be any reason to use a serial RAID, would there?
A serial RAID.
RAID with serial drives. A RAID of RAID.
Yeah, you can do that. Yes, why not?
That would be really fast, wouldn't it?
Yep, much faster, yes. The machine that the virtual PCs are running on is using a RAID,
Serial?
obviously. It's using the disks are serial ATA. Yeah. So that is RAID 0. Now let's see if I can get the markings off. The next one was RAID 1, right? Gotta get back to my mouse. What was RAID 1? Anybody remember? Mirror. Mirroring, which means that we write the data, everything gets copied. These things A to A, B to B, C to C. And then over here we have a second mirror, E to E, F to F, so a copy is made of each of these things. So that if one of them fails, let's see if we can use blue. If one of them fails, we can still run on the second system. You may have to go and make some modifications, tell it where to boot from, but you still have everything, and it is continuing to run. So it's the mirror of this thing. The next one that we're concerned about is RAID 5. And RAID 5 was the one, the magic word with RAID 5 is parity. This thing writes the data, it splits it up among the disks, and then at the end it has a parity stripe for each of these things. The parity stripe allows us to reproduce the data. If one disk fails, it can keep operating. So each of these lines has a parity bit that goes along with it that allows you to reproduce the data. The parity bit, the parity stripe has to be created every time you write, so that's going to slow things down. It tends to have a faster read and a slower write when we do those things. So based on looking at those things, what do you think a RAID 1.0 looks like? What's RAID 1? Mirror. And RAID 0 is stripe, right?
So it would be a mirrored stripe.
So a mirrored stripe.
Striped mirror. Woohoo!
So we have this thing here, and we got the data block coming out. So it mirrors first thing, and then it stripes.
That explains why I kept missing the practice question. I kept reading it as RAID 10.
RAID 10, 1.0. Yeah, I know. And some people do call it RAID 10. But the key here, when this thing went through, the first thing it did was mirror, right? And then it striped. We put the data in the mirror, and then it went into striping. So 1.0, the first thing it does is the RAID 1 part, which is the mirror, and then it stripes it. We also have a 0 plus 1. Let's see what it does, just out of curiosity. So if we go to the 0 plus 1, looks just like the other one, doesn't it? But how does it handle the data? Get the right one clicked. Notice that it stripes, then mirrors. So the order that the numbers in the 1, 0 and the 0, 1 appear in depends on whether it mirrors first and then stripes the mirror, or whether it stripes the data first and then mirrors the stripe.
That would be the best way to run it.
Yeah. That's what most servers today come with built-in RAID controllers, and they're going to be, I think most of them actually are 1 zeros. And then we could have something, what do you think a 5 0 would do? RAID 5, we had the parity stripe, right? What it does is take 2 RAID 5s and mirrors them, or stripes them. And then you could have a 5 1. So different types of RAIDs. One of the things that, yeah, we do have a RAID 6 here. RAID 6 is similar to RAID 5, except it has 2 parity stripes. And since it has 2 parity stripes, in this thing we've got a parity here and a parity here. And here we have the 2 parities and the 2 parities. It allows 2 disks to fail instead of 1 disk to fail. So in this one we could actually have 2 physical disks fail and the system keep running. Now, if it starts recreating the data from the parity, it's going to slow down. We've had that happen, and it's like, why is this server running so slow? And you go look and say that one of the RAID components, or the RAID 5 components, is dead. Replace it, rebuild the RAID. Does that visual help you any on how RAID actually works?
Yeah.
It is.
So if you can afford a RAID 6, you would want to do that.
If you could afford a RAID 6, that would be good, yes. Windows 7 supports RAID 0 and RAID 1. Yes?
What is the highest absolute RAID?
Oh, it goes on and on and on and on and on. I can't even remember them all. What you can do, what you can't do. When you get into striping, there's a number of different ways you can stripe. This shows a stripe on each disk. There's one of the RAIDs that has all the parity stripes on a single disk and how they're distributed across the disks. There are a number that goes on. These are the basic ones that you will see. And I think that the 1001 are going to be the ones that you see the most, because that gives you kind of simply, and without doing a whole lot of delay in the data write, data redundancy. The RAID 0 gives you the speed, and the RAID 1 gives you the redundancy of it when you do those. Somebody asked where this is. When you get to chapter to week 3, I guess I can move this up into week 1. Visualize RAID. I'll move this up into the week 2 stuff so that you can see it this week instead of next week. But that's the link to that website if you want to go back and look at what they do there. So we're almost done. Actually, we probably are done. But let's see what else is in the rest of these slides here. RAID controller card. Pass one of those around. Hardware RAID, software RAID. Software RAID is controlled by the operating system, which means that you can't install the operating system on a software RAID. It's one of those catch-22s, because the operating system controls it. You can't put the operating system on it because there's nothing there to control it. Hardware RAID you can put the operating system on, although they used to, and I don't think they really do anymore, they used to recommend that you not do that because of the delay, particularly in the RAID 5, the delay in the RAID. Well, they recommended that you didn't put it on a RAID 5 because of the delay, and every time you made a change, you had to recalculate the parity stripe. And the operating system makes a change a lot. Software uses the operating system, and that's one of the ones that you're going to do. All hard drives should be identical. When you do these things, if we have different size hard drives,
part of the space won't be utilized.
Part of the space, well, it might not be. Part of the space, what you said is right. We had different size hard drives. Then the largest RAID stripe that we can have is the smallest hard drive. Once you've created that, since we have 3 drives here, we can make that a RAID 5, right? We could come back over here and make this portion of it a 1 or a 0. So you can use them all, but you won't necessarily be able to use them all in the same RAID. RAID 5, all sorts of formulas. Let me tell you the simple way to figure out how much space you lose, because remember we had that parity stripe? You lose 1 disk's worth of space. If you have 3 disks, you lose 1/3 of your storage space. If you have 32 disks, you lose 1/32 of your storage space. You lose 1 disk worth of storage in a RAID 5. In a RAID 1, you lose how much? How much would you lose in a RAID 1? 50%. Because you're making a copy. A RAID 0, you don't lose any of your storage space. The RAID must be implemented before Windows is installed, but then it has to be, if Windows is installed on a RAID hard drive, and it has to be a hard controller, not a software. It's not a software. The RAID controller, again, we passed one around that you saw. You have to put the drivers on. Sometimes when you install Windows, if you have a RAID, you have to install the RAID drivers before you can install Windows. You may or may not see that. The general directions: install the drives, boot the system, verify the drives are recognized. You may or may not have to put the drivers on it. And then reboot the system. Control, what was that, 1? And then enter Control L and then enter the RAID configuration. You do have to configure RAID after you start these systems and these things. And you do need to follow their instructions on how to do it. The disks, this is the disk non-RAID, or this is non-RAID disk. In the BIOS is going to tell you how these things are configured. They can be made part of the RAID or not part of the RAID, depending on how you want to do it. Tape drives, floppy drives, I guess you need to know that they existed at one time. Tape drives still are in use. Oh, why do we use them for backup? Because they're portable, transportable. Hard drives are not designed to be shipped from point A to point B. Remember, we had that very close tolerance with the heads. You can do damage to them. Tape, not a big deal. Tape, well understood, used for lots for backups, and we're not just talking about little tape drives, huge reel-to-reel tapes, different types of things. They can be sent from location to location when you do those things. You may be able to support old floppy drives get dirty. One of the things, if you have to do one of these things, one of the first things I would do is try to clean it to see if the heads are dirty. Of course, then you got to find a floppy that'll work in it, won't you? Inexpensive way of backing up the hard drive. Write once, read many. Assures that the data won't be deleted or overwritten. That's something that the IRS needed, isn't it?
That's what I'm saying, yeah. They used it, they just don't read it.
Yeah. Data stored sequentially, and this is the problem with these. It's stored sequentially back to serial, in my way of thinking of serial, which means that, and that's the way you do tape, isn't it? If you ever listen to music on tapes, you ran the tape forward to the song that you wanted. Same thing here, you got to run the tape forward to the location that you want. One of the things about backups is restoring is not fast. If you have a backup, don't count on getting things up in 15 minutes because it takes a long time to restore these things. That's why RAID is good to have to keep running, and then in the middle of the night, then you can do your restore. RAID is not designed as a backup. The point I like to make, a backup is it's for disasters, not for a hard drive went down, but you show up for work and the building's gone. Now what you going to do? Well, if you had all that stuff in the NOC, it's gone. So backups should be stored off-site someplace, preferably outside of the immediate area.
The OneDrive for our email account.
Well, yeah, something like that. But you can do that, and I think replication, more and more people are going to replication as we get faster and faster in the WANs, to store it in a cloud storage someplace. But when you're talking about a server, a cloud storage that you know where it is and you have control over, because AJ's shaking his head, he's right. The problem with cloud storage is you don't know where it is. It could be stored in China. India. I don't know how many data centers are there. Hong Kong, I know they've got some. What a lot of data centers are for, and each of those countries have different laws. What a number of companies are doing are building data centers to have the backups put in Switzerland.
You know, NSA has a problem.
NSA has?
They have a copy of everything.
Yeah, kind of.
You just can't access it.
The ISPs are kind of starting to fight back now with the encryption. So we'll see what happens in this whole thing. But tape drives back up, replicate however you want to do it. But in any case, you should have a backup of some sort, be it tape or wherever else. Full-size cartridges, mini cartridges, lots of different things. And you would think that tape is cheap. If you go look up the price of a tape drive for backup, they ain't cheap.
$300?
Something like that, yeah. Maybe more than that, depending on how much data you need to back up. This is the same thing we're talking about backing up off-site. How much data are you going to back up? If you've got 4 or 5 terabytes a night, maybe not so much so.
Old computers, I remember using one that had a cassette recorder.
Yep. Cassette recorders, that was before floppies.
Yeah.
Serial loading, yeah. Well, the first computer class I had these great big, huge, they were hard drives as a mainframe that every time you wanted a program, you had to put that disk into the computer. That was a while ago. Floppy disks, just know a little bit about them. Yep, we had them. Yep, these old machines that we've got some of them have them. Hopefully you're not going to need them anymore. They didn't do a lot of storage. If you're going to do anything, if you're going to store anything now on that type, theoretically, of media, you're probably going to use a flash drive instead of something like that. Like you do a hard drive, if you connect the cable the wrong way, the drive light will stay lit, and this is one of the troubleshooting things. If you got, and I think you get an error message. I think we're not hooking up monitors to these machines when we do this stuff, but I think you get an error 47. But the cable with the twist, the one with the twist is the A drive. So the A drive goes on the floppies in the BIOS. The A drive and the B drive are reserved for the floppy. C and D are reserved for the hard drive and the CD. And then everything else just gets the next drive letter. So we finally got to the end. The different sizes. I think the sizes and what they do and how they connect and the rotational latency, those things are important. And SSDs, how they work, you don't defrag SSDs and what defragging these are about. How RAID works can be something that can be really important to you when you're working in your field and actually doing these things. What I want to do now is do the little demo for you to how you configure a RAID. And Todd and John, John, can help you because they've had the Windows classes and they've had to do this. This is not rocket science, okay? So, I think there are a couple of you haven't used the virtual machines, and we'll go through those real quick. virtualpc.skyline.edu is how we get to these things. I see a lot more of them than you will, I hope. I was fooling with this one today.
Password vault administrator.
Yeah. Watch my new video, except I messed it up. I forgot what password I put in. Now I got it. You can configure these things just like you do a real machine. So I can make this bigger so that hopefully you can see it.
I can see your connection.
It's not all of them.
It's all up here on the screen.
I mean, on the bottom, it's showing the recent event where you've been disconnected and reconnected.
Oh yeah. Oh yeah. Because I was doing I put a new video on. If you really want to know how to hack a server, I think it's a 7-minute video.
Didn't you show us that?
Where that was Windows 7. I did this one even faster.
Okay.
Figured out a new way to do it. You can just boot to the install media and go into command prompt and change it. So if you're interested in those kinds of things, look on YouTube. Look on YouTube. But anyhow, to do these things, we're going to go to Administrative Tools, Computer Management, and in the Computer Management is going to be Disk Management. And Disk Management is going to read these things down. Red down arrows are never good. Would you agree with that?
Yes.
So what we got to do is go in here and right-click on these things and put them all online. Didn't change the arrow, did it? So I can initialize the disk, and I just initialize all of them at the same time, just 1, 2, 3, and 4. Disk 0 is where my C drive is. I'm not really going to mess with it. Windows has 2 types of disk. They all start out as a basic disk, and you notice if you can see this here, it says basic. Let's see if I can draw some really stupid little lines here. Disk 2 here. Basic disk. A basic disk is one that we just installed. What we're going to do in order to do the clever stuff like RAID is convert these things to dynamic disks, which are controlled by the operating system. A basic disk can have 4 partitions. It can have 3 primaries and a secondary. A dynamic disk can have however many drive letters, however many letters of the alphabet there are. But we have these things, so let's don't convert it because it'll do it for me. Let's do we can do a new simple volume, a span volume. Let's do a stripe. If I go to the stripe, you notice I don't have a next because a stripe takes how many disks? 2 to 32. So we have to have a minimum of 2 disks for a stripe. And remember, a stripe has no data redundancy. Well, what I do now after I have these things in here is the maximum available. Select the amount of space in megabytes. I like to do these really small because the objective is not to make big disks, but to learn the process. So we'll do 250 megabytes. And notice when I do 250 megabytes that my total volume size here is 500. Because it's taking 250 meg from each disk. Okay? And then we can go back here, let's get rid of that and get my mouse back. We can go next. Assign a drive letter is going to be E, and we'll call this default. And this is how you can do the allocation size. I'll just use the default. We'll call this was the stripe, right? When you do these things, perform a quick format. In the formatting world, a quick format just rewrites the directory and doesn't check the disk for errors. Notice that I got a little pop-up, and the little pop-up error, which you probably can't read from back there, but it says the operation you selected will convert the selected disks to dynamic. It's one of those Windows things that says, yeah, well, I really think it'll let you do it until you get to the last step and says, no, you can't do that. It drives me crazy when that happens. Oh, I can do it, I can do it, I can do it. And the last step said no. This one at least says, it will convert them for me. Do I want to continue? And I say yes. And you notice they just changed to dynamic. So we have these dynamic disks, and we now have a healthy stripe. We have 2 disks in our stripe, single drive letter. So we're taking part of the storage from each disk and making it a single drive letter, single volume. If I wanted to convert these disks to dynamic, it's really tough. I just right-click, convert to dynamic. And we can do 3 and 4 here just to get them done so we don't have to wait for that the next time. Because, next thing, let's go in and do a new RAID 5. So we add RAID 5. I still don't have a next because our RAID 5 is 3 to 32 disks. Now I'm going to go down here and say that I want to take 250 meg from each of the drives, and the storage space that's available here is 500 meg because 1 disk's worth of storage gets dedicated to the parity stripe. So you lose in a RAID 5 1 disk's worth of storage, depending on how many you have. Actually, let's try that one out, because we did 3 and we lost a third of it, right? What if we picked 4 disks? Let's cancel this. Let's get back to the mouse. Cancel this, and let's do a new RAID 5. And let's add space from each one of these, and we'll do 250. So based on what I said there, we should have 750 meg of storage, and that's exactly what we have, 250 from each drive minus 1 drive's worth of data. So we can next, and again, the drive letter on this one, and sequentially, if you want to pick your own drive letters, you can do that to drop down. Next, and we'll call this one RAID 5. RAID 5, and we'll do a quick format on it and finish up. And making the RAID. So we now have a RAID 5 here, and notice this thing conveniently color codes each of them differently so that it's easy to see which disks are assigned collectively together. And now we have 4 disks that are all controlled by a single drive letter. When it writes the data, it's going to write it simultaneously to 3 of those letters and put the parity stripe on the 4th physical drive. Is this making any sense on how these things work? Making more sense? The other thing that we haven't done yet is a mirrored volume, right? And if we put 250 meg on the mirrored volume, well, actually I guess we got to add something. We got to have 2 disks for a mirror, right?
Right.
We add 250 meg and we get 250 meg. 250 meg from each, we lose 50% of the storage because we're making a copy of everything. So everything is mirrored, a copy of everything, and this is going to be our mirror, and we'll do the quick format again. Finish. And it should, here in a second, pop up. We have the mirror. We have the 2 G drives. So when we write something to G drive, the same information gets written to each drive. Does that make any sense? Creating RAIDs, software RAIDs in Windows, pretty simple process. It's just a matter of, I'm a believer, it's just a matter of doing it. None of this stuff's really all that difficult, but it's, until you do it, I don't think it makes as much sense when somebody just does a demo.
Yes, I agree.
Are there questions? Going once, going twice.